Russell Tackett, HydraForce, electronic sales and application engineer, to talk the EVDR 0201A advanced training demonstration. I'm going to start by a review of the configurable controllers that I did basic training for the 0201A. The first controller is the EVDR 0101A, simple one output, one input type controller. Has one input, voltage, current, resistance, pulse, M, a single valve drive, so it's got one PWM output. It's 1A. 01 is the first two letters are the outputs, the setters are the inputs. There's an input and error monitoring, 9-volt range, up to as far as control output, 40 to 400 hertz, environmental P69K, A to D converter, and temperature range -4 plus 85, and CE certified. The excellent analog replacements. The reason they're digital controllers, so there's no pop adjust, no valve over time with the aging controller. So valve output intensity, programmed on the PC for easy replacement. Can valve up to 2 amps. No need for different part numbers for different current ranges. Some of the input or analog controllers would have a of 300 to 500 milliamps or up to 2 amps. This is good for everything up to 2 amps. Some of the DIN type connectors that were on the analog controllers to Deutsch, either Creatus, coils to a Deutsch type coil, and HydraForce has both DIN type connector coils and Deutsch connector coils, so that change out. Or if you need to make your own harness like you did in step 1 there, there's some part numbers from HydraForce that help you in doing that. EVDR 0201A, which is the focus of this demonstration, plugs on it just like the 0101A did. 2-pin one side to connect to the coil, and then this one has an 8-pin Deutsch on the back side face to your machine, whereas the 01A had a 4-pin Deutsch. 2 analog input, LED monitoring also, operating 36 volts, drive 2 amp coil, 40 to 400 hertz, 16K, 12-bit A to D converter, extended to ranges. Replacement for the 0201 controller that we currently have with HydraForce, and things that are updates on this controller. It's got a different in it, it's a faster processor. It's got LEDs integrated in it to be able to tell you which output you're driving, and as far as intense changes on how hard you're driving the output. Some of the additions, you got output ramps, you got J19 improvements. There's on both the 0201 and the 0101. Both a general purpose valve driver. The 01 has a fan drive with versing function. Like generator control, which the closed loop control, available, still working on that now. Then the 0101A has a transmission valve control. HFM is the program we're going to use to set up this controller, available charge through our electronic portal, and you're going to USB to CAN converter, either a Kvasser or peak system. Another show us some of the different screens, but we're going to explore this in great detail in a second. And the development kit, basically a controller in a box. It has all the cables you need. It has the USB to CAN converter you need under one part number, and there is a cost savings. Mail, electronics.support@hydraforce.com. General information at just hydraforce.com. Portal has a specific information, so the website, services and support, and electronics portal. And another demo that we're going to do to demonstrate the CAN functionality of this controller. And this, just like the basic and presentation, the startup guides for both the 0201 and the 101A on setting the controller and what type of screens you need to look at, and just general setup procedures. Okay, I'm going to bring on a couple things. The first pulse takes to start. I want to bring it over. So I've pulse. I'm programming calculator, just a standard Windows calculator in programming mode. And I'm also going to press my USB to CAN converter to tell us what's going on with our controller. We turn HF impulse. This is the initial screen. I'll go to tab and do a start, just like we did the basic explanation. Tell CAN adapter I'm using, tell baud rate I'm communicating at, what stuff I have. It's found a 34, so it populates this when I hit the select button. Download any firmware. In other words, change your valve driver to a fan driver or a generator control. You would do that through this function here. Program that I've been working on for the J90 this is going to alert to the presentation or the discussion we just had. 0 to 5 volts. I've got it open right now, so we can volts and 0 volts, but I'm leaving it at 5 volts. If you would enter it there. I am now at an input 1939 as opposed to the input we had before, or the external settings, and want that by doing the pull down external input. Leave it at J99. This would be a 10-bit signal, so 0 to 1023 is a segment in for this J1939 message. And again, at the not digital input, but I'm going to drive a PWM output. So I'm driving both of these coils at the same time, but they're different ramp rates or different rates. We're at 3 breakpoints. This one only has 1. And one's compatible. Output at 200 hertz because I'm using the same coils and valves I did in the previous patient. Depending on what you want to drive, the mixer's data will tell you where the ideal frequency needs to be for that valve. And once controllers, the 0101A and the 0201A, will drive anything from 40 hertz to 400 hertz. Settings, I'm going to transmit my information analog input on 6450 every 100 milliseconds. I'm going to command messages for coil A on 61440 and receive B messages on 61441. Going to start bit 1, so byte 1, bit 1. The length along as far as 10 bits, and to look for that for the 1 second that I'll set a fault. Same screen as we saw before. The controller, download, then log on. We know in the presentation before our input was driving valves, but it is no thing. It's transmitting a message. So this would be for like a pressure transducer that is sitting in the J1939 bus. If he can view information, we notice that there to this software either a receive section or a transmit section. Now that we are transmit information on 61450. This information here is hexadecimal, so I need to convert it from decimal to hexadecimal. Calculator, programming calculator. If I can 6150 and can hex a value of F00A. If we look up 00A, 22 is the piece of information that is being transmitted from the controller. The 1939 address of the EVDR is 34. If I can 4 in it's 22. So this message F0A22 is on the the analog input. So if I monitor around, we can see that the bytes 1 and byte 2 get moved. So byte, high byte. So if I key in hexadecimal 0C29, the decimal, it's 3. This is in millivolts, so 713 millivolts or 3.11 volts. So these two correlate. Other transmitted is coil current of A, coil current of B, and power supply. Okay, so we'll go ahead and turn on messages for the outputs. The outputs are 61440. So by my calculator, 61440. And is F000. So F021 is just a source address I gave for my computer. So I will transmit information every 100 milliseconds to the controller 6602 and then a CD. And those are in hex. If I turn on my messaging, both command A and command B, we can see I drive in outputs on the coil. 800 milliamps. If we go to the command at 800 milliamps, 512, we should have 100 milliamps. My command to A to be 5. Once again, we need to go from decimal to hexadecimal. Function of this pecan view, it shows things in hexadecimal. Some of the products show things in decimal out there. So if I 200, so and 00, remember low byte, high byte. So 0 2 hit OK. Okay. 0200. Hexadecimal. Done something wrong. Decimal 512. I've done something wrong here. 0200. What was the 600 milliamps? No, that is right. I'm sorry. Will give us a current of 600 milliamps, which is what we need. Sorry, I was confused for a second. Okay, so since we don't have the messages being transmitted, just like in the basic presentation we talked about, there's a way to manually give a value to the coils. And the same thing here. Once our say 1939 messages, so I've got the ability to turn on main for each coil A and coil B. So this is how you can having your controller configured, or if you just need to do test bench setup. Dating, upper right hand corner, charting. I'll export the data to that right there. I will file using Excel. We can see the time on my computer is 1:18. So 1:18 values for my A coil current, my B coil current, and my signal, signal that my analog input. So this is advanced way to get the 0201A to be driven by J1939 commands and transmit the value of the analog input onto the J39 bus. Next idea for having a distributed control where you've got a controller that's sitting on a valve manifold somewhere in the machine. It can very easily a small wiring harness coming from that valve manifold back to your master controller. I want to conclude by reminding you of the devices that we have in configurable controller, both 101A and 0201A. We know that in different configurations or different derivatives, the different course, the 0101A has one PWM output and one analog input. no CAN chip. The EVDR has 2 inputs and 1 analog input. Any, please feel free to email us at electronics.support@hydraforce.com. Thank you.